I'm just trying something here. I'm going to record your lesson tomorrow for period 6. I won't be here period 6, so I want period 6 to hear your lesson tomorrow. So when the sub comes in, they can just play it. I'm practicing right now. I just want to see if this picks up my voice from there to there. Okay, so that's what's going on. So this is kind of being recorded, I guess. All right, you ready? Okay, so yesterday we talked about arithmetic sequences, write the formula for it. Well, today we're going to do the same thing, but except it's, hang on, except it's going to be the sum of a finite arithmetic sequence. So here's the deal. You're on your 6th slide right now, right? Okay. I don't think this is on your slide, so just read it with me, please. This person, Carl Friedrich Gauss. Carl Friedrich Gauss is a mathematician back in the 1700s. He was asked, as a student, to do this. Find the sum of the first 100 integers. So basically, from 1 to 100, find the sum, add them up. Get an answer. Well, back in the 1700s, there was no calculator. Couldn't use his calculator. He couldn't Google it. That's what somebody said in period 4. Couldn't do that. So what's he do? What would you do if I said add 1 through 100?
Write it out.
So you have a pencil. And you're going to write it out and go 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. Right? Is that what you're going to do?
Yep.
Okay. You're not going to try to speed up at all. You can take the long route and just start going. Everybody can do that? Figure out an equation, maybe. He didn't do that. But I want to show you what he did, because here's what he did is going to allow you, all period and the rest of the chapter, to use his formula to get the sum of an arithmetic sequence. Here's what he did. He went like this. He took 1 plus 2 plus 3 plus 4, and he just kept going and going, and he put his dots down all the way to what? 100. Okay, so that's what I'm asking. He was asked to do this, so he did that. He just wrote. He didn't write all those numbers, but he just said 1, 2, 3, 99, 100. Then he did this. He backs up and he says, "I'm going to write this out again, except I'm going to go like this." So he basically starts at 100 and goes all the way down to what? 1. Okay, so this is the answer up here. Then he doubles his answer, but he writes it backwards. Why does he do that? Because he did this. He drew a line. He added the two equations together. Okay, so 1 plus 100 is 101. Plus, these two make 101. These two make 101. Will it make 101 all the way? Yeah, it does. It looks like 101 comes up every time. But then he realizes, okay, this is truly the answer. This is the answer again. It's double. The answer is too big, twice as big. Okay, so then he says, okay, 101 plus 101 plus 101 plus 101. He realizes he has how many 101s? There's only 50 here? That's 1, that's 2. Yeah, there's 100. Isn't there 100 101s down the line? So he says, take the 101 and take it times 100. That's how many terms I'm adding up. I'll take that 100 times the total. But of course, this answer is how much bigger than the real answer? Twice as big. Okay, so then he does this. Well, if the answer is twice as big as the real answer, he cuts that number in half. And he says, this must be the answer. 5,050. Okay. But now, here's what I want you to do. Look at what he did. He was asked to take the first 100 terms, add them up. Well, there's the 100 right there. But it got cut in half, didn't it? So really what happened was he was told to add up 100 numbers. He takes it and he cuts it in half. That's what he did. But this 101 is the trick. How do you get this 101?
First and last term.
The first term 1, the last term 100. So basically it's the first term plus the last term to get the 101. And this will get the answer every time. Now, I'm going to clean this mess up. Ready? Here it comes. The mess, I'm going to clean it up, is going to be this. Oh, I already blew it. I'm sorry, I blew it. This is not going to be A sub n. This is going to be S sub n. What's S stand for?
Sum.
The sum of how many numbers? Well, for us it was 100, right? Okay, so what goes here, guys? What goes right there? It's going to be n, this number. I added 100 numbers, you put the n there. But what did we do to the 100 numbers? We cut them in half, didn't we? So the formula would be, however many numbers you're adding, take the number, cut it in half, take it times. Now what's this going to be, these two spots? 1 plus 100, but 1 is the what term? First. So it'd be the first term plus 100 is the what term? Last term. Well, what's the last term in my sum? A sub that number, whatever that is, A sub n. Right? So I'm just trying to show you what he did to get this answer, 5,050. More or less, he was asked to add 100 numbers. He cut it in half because he knew this was twice as big. So it turns out to be this, and I'll take this off now, but this is all it is right there. The sum of your sequence, if you add up 50 numbers, 100 numbers, 200 numbers, will be n over 2 times a1 plus an. And that's your formula to get any sum of an arithmetic sequence. Did you hear that? Arithmetic. It's got to be an arithmetic sequence. So maybe behind it, just write this. This can only be used if it's arithmetic, not anything else. Here's the other thing it could be. It could be geometric, and geometric is tomorrow. What did we do in 9-1? In 9-1, we did arithmetic, we did geometric. You didn't know that, but that's what we were doing. And we did oddball ones, just off the cuff. So this formula can only be used if your sequence is arithmetic. How do you know if something's arithmetic?
The D interface is constant.
Common difference is the same, right? It's got to be the same the whole way. Okay, so you know what? That formula will be used on the next 5 slides. We'll probably be done pretty quick because it's all we're doing is right there. Okay, first question I have for you is find the sum of the integers from 1 to 35. I just asked you to find 1 to 100, now 1 to 35. I really feel this helps to write out the sequence. Sorry, I'm going to change that on you a little bit. I'm going to put a plus there. The sequence is 1 plus 2 plus 3 plus 4 plus ... 35. The first 35 numbers in your sequence. Add them up. And there's what you just learned on the previous slide right there. Okay, I'm walking around. I need some answers. If you have a point. Okay. Oh, then. Hey guys, if this is easy, just go to the next slide. I'll catch up to you. I just want to see some answers though. Yep. Yep. You get it? Not yet?
Right.
Yep. That's it. Did you get it? Not yet. I probably have half the class right now with the answer, so I'm just going to get started. So remember how this worked for Carl Friedrich Gauss? You know, he wrote that out, right? And then he reversed the order. I don't know if you remember what I said here? If he reverses the order like this, 35, 34, and he keeps doing this all the way down to 1, what did he do? He drew a line, he added down and got what? 36. That 36 comes from this and this. First term, 1. The what term? Forgot to write this. S of 35. Aren't we doing 35 terms? Give me the sum of the first 35 terms. This will be what? Up there? 35 over 2. First term is 1. This is the 35th term, the last term. Well, look. I already know it. It's 35. This is a really nice problem because you know the last term. So basically, 1 plus 35, 36. This divided by this was 17.5. Then I looked around and I saw half of you already had this. You had what? 630. How about the other half now? Are you okay? Some of you didn't get that when I walked by you, but are you okay now? Okay, nobody put a hand up, so we're moving on. Okay, good enough. All right, let's do it again. Find the 50th partial sum of the arithmetic sequence. All right. So tell me how many numbers I'm adding up. 50. There you go. You should know that's how you start. The sum of the first 50 terms. Do you see that as being a problem? You don't know the 50th term? Because you don't know the 50th term, go back to yesterday, because yesterday I taught you how to find the 50th term. All right, I'll give you a minute to come up with an answer. Some of you might have it, because you've already been working on it. Anybody? You know it? Yes, that's it. You get it? Yep. How did you get to that? But you like the formula, right?
Yeah.
Yep, that's good. How did you get it? You did the formula?
Yeah.
Yes, okay. Nothing yet? Nothing yet? Got a couple people with the answer right now, just 2. That's the easy part, isn't it? I'm going to add 50 numbers. Cut it in half. The first term is -6. The last term, the 50th term of that sequence is, and here's the problem. You don't know it. That's why this problem got harder on you. So how do you find the 50th term? Without writing 50 terms. The formula, if you want the nth term, if you want the nth term of any sequence, arithmetic sequence, it's going to be this. Right? Isn't that what you did yesterday? Okay, first term, -6. Common difference. What is the common difference?
4.
It is 4. If I take the second term and I subtract the first term, I get 4, so it is 4. Do you guys see this sequence as a positive sequence? It's going up, 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 right? So that's got to be a positive difference. Okay, so that's 4n. Take away 4 with a negative 6 out in front. The formula is 4n what? Minus 10, okay? All right. You want the 50th term? The 50th term would be a sub 50. Put it in your formula. 4 times 50, take away 10. 190? 190 goes here. And now it just becomes a calculator problem. Hang on, let me get a little more room. This will become 25 times 184, 4,600? Yep, okay. There you go. Good? You know what? When you guys get to your assignment, you have to write a formula to find the last term. Unless you're just lucky enough, if you're lucky enough to see the last term, then you're lucky. But you aren't that lucky all the time. Okay? All right, go to the next slide. You know, if I were you, I would create a sequence of numbers and then look at the sequence. Determine the seating capacity of an auditorium with 30 rows of seats. If there are 20 seats in the first row, 22 in the second row, 24 in the third row, and so on, and so on. See this? That is your auditorium. In the first row, there's 20 seats. Second row, 22, 24, 26. Dot, 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 until you get where? 30th row. Bad deal. I don't know the 30th term of my sequence. Here's my sequence. First term, 20. Second term, 22, 24, 26. Dot, 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 dot. Until I get to the what term? What term is that? Yeah, it's the 30th term of your sequence. So this is the 30th term. Go for it. It's pretty big, by the way. Got it? You don't think you got it? It is. It is. You got it, just show me. Yes, that's it. Do that one. Once you get the hang of these guys, they're all the same. All you're doing is adding terms. Question is how many terms?
So since each of the rows are compound.
Yes. Well, the thing is, that number stands for the first row, second, third, fourth row. So there are how many terms in your sequence? 30. Because there's 30 rows, right? Yep.
Minus 8.
I put the first 4 rows down. By the time I get to the 30th row, how many numbers were there? In my sequence, how many numbers am I adding up? 30. This is the first term, second, third, fourth. I keep going until I hit row 30. There are 30 terms, so this is what I want. I want sum of the first 30 terms. Well, that'd be 30 over 2 times, first row had 20 seats. What did the 30th row have? I mean, you can sit there and go like this. 20, 24, 20, 22, 24, 26, 28. You can sit there and count until you get to the 30th row. Or you can do just make a formula. I'm kind of hoping you make a formula. A sub n equals a sub 1 plus d times n minus 1. First term, 20. What's the common difference in this sequence? Up to 20 plus 2n minus 2, right? That'd be 2n plus 18. If you want any row in that sequence, you want to know how many seats are in it, just put it into your formula. So I want the 30th row. Answer would be what? What'd you guys get?
1,400.
No. The 30th row has how many?
78.
78. This is why this is hard. It's the last term that's not visible. Many times you won't know the last term. So you put it right there and you say 20 plus 78 times 15 equals the sum of the first 30 rows. Now say it, Alicia.
1,470.
1,470. 70 what? Seats. That's the answer. There's one more story problem. Finish it up. It's almost the same thing. Actually, this next one, the sequence isn't that long. So it's actually, if you really didn't want to use the formula on the next one, you could get away with it. But use the formula. Let's just get practice. Which question says how much money are you going to make? 6,000.
Oh, so then I have
In the first year, you made 2,000.
so then there's like
And you're making 32,000 every year. I think you're way up there.
okay.
100. You must have got fired to get that number. You made that? You got it? Did you get it? No? Did you get it? We have a 4 or 5 people right now with the answer, and I think some of you've got good numbers. I think you're going to get it. I really do. All right. Consider a job offer with a starting salary of $32,500 and an annual raise of $2,500. Every year you get $2,500 more. Determine the total amount of compensation from the company through 6 full years of employment. So really, I want to know the total compensation. How much do I get paid in 6 years? Wouldn't that be add up the first 6 terms? First year I make 32.5. Second year I make what? 35,000. Add another 2,500. Keep it going, keep it going, keep it going. You know what I want to know? The last term, a sub 6. See, this is one of those problems where you could have just thrown all the numbers in, take your calculator, add it up, get the answer. But I don't want you to do that. So this problem says, give me the sum of the first 6 terms. Fill it in for me, somebody. This is what? 6 over 2. First term. 32,500. Last term, that would be the 6th term. This is where problems always happen in this kind of problem. You don't know the last term, so now this is where you could just sit there and add 2,500, 2,500, 2,500, 2,500. You'd get it, but I'm not going to do it that way. I'm going to do a quick formula. Formula would be first term plus common difference times n minus 1. First term. 32,500. Common difference. 2,500 times n minus 1. Formula is 2,500n. That is minus 2,500. Off of that, wouldn't this be the formula? So if you want the 6th term, go get the 6th term using your formula. 2,500 times 6 plus 3,0,0,0. What's that answer? 40 what?
500.
I think it's 45,000.
Oh, sorry, yeah.
Yeah, it's 45,000. So this would be $45,000. On your 6th year, guys, you're making that much money. On your 1st year, you were making this. Add the two together, 77,500 times 3. You make how much in 6 years? Is it 000 or is it 500? 500? Okay. 500. Just short of $250,000. Okay, and there it is. Now, do you guys realize this problem had only 6 terms? And if it only has 6 terms, you guys could have done this, couldn't you? Couldn't you have just filled it in? And I mean, this is actually a problem that you could have handled without doing all that work. You could have just added all those up and got this number. But I was trying to use the formula to help you understand the formula, okay? That's all I have. You okay with that? All right. No movement. We're good? Nobody got a hand up? Okay. Go to work.